Good afternoon, everybody. I'd like to thank you for joining us for UMBC's GIS webinar. I am Dr. Erwin Villiger, Director of the UMBC Master of Professional Studies in GIS. For those of you that are not familiar with the MPS in Geographic Information Systems, it's an evening and hybrid online program located in Rockville, Maryland, designed for those that need a little more technical understanding of GIS. We focus on the system side of GIS by concentrating on application development, spatial database development, web development and services, and advanced analytics and visualization. If you feel like you need to advance your technical skills, check out our program. We have a full master's degree, but also a graduate certificate, and we're currently developing advanced graduate certificates focused on specific areas for those that have a solid GIS background. Have a look at our website or contact me for more information about the program. Now, this webinar series seeks to provide insight to goings-on in the geospatial industry, to look at innovative new applications and technologies, and to highlight topics that are relevant to GIS professionals. The growth of social media over the last decade has revolutionized the way individuals interact and industries conduct business. Individuals produce data at an unprecedented rate by interacting, sharing, and consuming content through social media. However, analyzing this ever-growing pile of data is quite tricky, and if done erroneously, can lead to wrong inferences. In this webinar, you'll gain, by example, insights to mining social data, social media data, and exposing underlying latent structures relating to ideology and sentiment, as well as space and time. I'm very pleased to have an outstanding speaker today. Richard Heimann is Chief Data Scientist at L3 National Security Solutions and leads the data science team at L3 Data Tactics. He is also an NSS Technical Fellow and an EMC Certified Data Scientist with concentrations in spatial statistics, data mining, big data, and pattern discovery. Richard is an adjunct faculty member at the University of Maryland, Baltimore County, where he teaches in our program. He teaches spatial analysis and geoprocessing, as well as occasional seminars on socioeconomic data analysis and related analytics. He also teaches for George Mason University on human terrain analysis and recently published a book titled Social Media Mining with R. If you have any questions as the webinar proceeds, you can enter them into the GoToWebinar question panel, and we will address them at the conclusion of the presentation. And now I'd like to hand the podium over to Rich Heimann. Rich?
Thank you, Erwin. Just bear with me for a moment. I think this should successfully launch my presentation. Thank you for the introduction again and hosting this event. So with the help of Keegan Hines, who's a fellow data scientist at L3 Data Tactics, we tackled sort of this problem of analyzing Twitter data following the aftermath of the events in Newtown, Connecticut. This analysis was done for the purpose of this webinar, so hopefully you'll get to see something that you've never seen before. I will note that there were certain sensitivities in analyzing this data. We sort of understand the gravity of analyzing something of this nature. However, it's important when we talk about using social media data that we're not using it only for maybe sort of these empty type of questions, but also thinking about how we could use this media for inquiring about socially critical problems. And certainly the sentiment and the ideological discussions related to gun control following this event are socially critical questions and deserve attention. So, without further delay, the general outline for today's talk is noted here. I think the goal of data analysis, which I'll most of the time when I say data analysis, I'll be referring to quantitative data analysis, which I might call analytics. I think is a true, generally speaking, for spatial data analysis or spatial analytics, and it's just an attempt to transform our data into information, information into insights. And those insights ought to be both non-trivial and hopefully socially critical. So the goal of this webinar is to show some value of quantitative analysis, and that's contracting it against maybe things like qualitative analysis. And so that certainly deals with these sort of new emerging data sets, these non-traditional social science type of data sets, including Twitter. So I hope to show by example how useful these non-traditional data sources can be, and then also show the usefulness of those data and sort of contextualizing it with certain elements relating to space and time. So, so before we could get into this, I think the analysis ultimately is going to be pretty compelling. But from like a social scientific inquiry perspective, I want to do these things pragmatically. Likewise, the presentation is a little pragmatic. So we're going to talk, we're going to sort of lead up into the case study by laying down some fundamental ground rules of important sort of perspectives that we ought to have when sort of pursuing an endeavor of this nature. So first, we should talk about what is counting and measurement, and this is a table that I stole actually from another colleague of mine who was writing about the various modes of inquiry from an analytical perspective, and so he saw those, and I would agree with this evaluation that there are really only three. There's qualitative, there's this sort of deductive query-based approach, where you ask a specific question in a deterministic way, get an answer, and then there are analytics. So this is important because I think the precise nature of quantitative data analysis, which again I'll mainly call analytics, is a common source of debate. So I think a positive definition for analytics must describe its role in this sort of research process. So while also clarifying its scope vis-a-vis other analytical frameworks. So the defining characteristic of quantitative data analysis or analytics, I think, are the fact that they're relational and probabilistic. So though analytics can be merely descriptive, it has the most value when it's a relational tool. So this is pretty important. So analytics focus more on the association and interactions rather than examining a variable or a single characteristic. So in the table above, instead of asking list all items in X with characteristic A, an analytical question might be, what is the relationship between characteristic A and B within the group of X's? Okay, so this focus on relationships makes analytics uniquely useful in identifying patterns within and between observations. So analytics, again, is probabilistic. In the relationships it defines, we sort of find them to be generally true and hold in the averages, but do not necessarily hold for every individual observation. So hopefully that's clear. I would encourage you to go and read sort of the entire evaluation of both of those three modes of inquiry. The goal of this webinar, excuse me, is going to be this quantitative approach. So we're going to try to understand things probabilistically and the associations and also large N. So if we go back here, these qualitative pursuits, what are persons A's intent, these are largely narrowly focused. They focus on small N, so few number of observations, where analytics, our goal is to get a much larger set and hopefully increase our sort of power in our analysis. Okay, so counting goes further. I think counting ultimately, and the modes of inquiry noted in the last slide, are about how precisely we count. So in this slide, moving from A to D, we notice all have varying sort of ambiguous terms of counting, with the top maybe being the most precise and the bottom being the least precise. So in D, do all Americans favor gun control? No, this is sort of hyperbole. And I've added sort of the geographic equivalent into each one of these examples just to sort of enrich the discussion. So the reality here is simply that you may hear words like many, much, some, numerous, a little, a lot, etc. What you're probably listening to is an analysis conducted in a qualitative way, very different than what I hope to show later on in the case study. Or you're listening to somebody who's trying to mislead you with attempts to appear quantitative and rigorous, but in fact they're using these sort of ambiguous terms in a misleading way. So the point, if you hear these things, you should be maybe a little leery, and if not, just run away. So this brings me to a great quote by Bill James, and he, I think, sort of captures why quantitative data analysis or analytics are so important. And his quote is, the analysis, or excuse me, the alternative to good statistics is not no statistics, it's bad statistics, excuse me. People who argue against statistical reasoning often end up backing up their arguments with whatever numbers they have at their command, over or under adjusting in their eagerness, excuse me, to avoid anything systematic. So I think the point here, hopefully the takeaway message, is that quantitative data analysis is about more than just reporting data points. It's about relationships, it's about associations and interactions, ultimately delivering context. It's not about cherry-picking data and results. So I dug up a few examples in sort of a geographic context of using numerical values to support qualitative analysis, and I think this is what Bill James was cautioning against. And you notice that all of these have similar characteristics. They're all small n, where n is the number of observations. They're often just examining one variable, sort of inquiring one variable at a time. Quantitative analysis, again, is about more than just small n in one variable. It's about interactions, relationships, many variables, and larger n. Okay, so that leads us, I think naturally leads us to a short discussion about measurement. So the goal of measurement is to arrange items or observations on a continuum. And in this example, what we're trying to do is arrange observations where the unit sort of a measure is a person, and what we're trying to measure or place on this continuum is their level of sickness. Okay, so this is good. This here is a great quote by Yogi Berra. You could see a lot by observing. We could observe sickness. We could observe height and weight and many other variables, and we can measure them directly. This talk, I'm going to talk a lot about ideology and sentiment. These are things that can't exactly be measured directly. So how do we measure things that, like sentiment and ideology, that are unobserved, for which there is no direct measurement? So this is an important question, something that I think we're going to tackle a little bit later, and how to explore these unobserved type of qualities in our data, or these latent structures. This is really what we're going to get into a little bit later, and we're going to try to pull out these topics or themes that people are talking about. And we do that in a pretty clever way by looking at the things that we can observe. So we could observe maybe Twitter users, or what we'll sort of call documents later, and what words people choose to use and not choose to use, to try to estimate this topic idea or theme idea that we definitely can't measure directly. So that's sort of a teaser of things to come. But before we get there, I just want to touch on briefly a little bit about traditional data versus non-traditional data, and really I think the sort of juxtaposition that people associate with traditional data, aka good data, and non-traditional data, aka bad data, and hopefully debunking some of these notions. So I think if you wanted to approach this from a traditional social science perspective, it's you would evaluate or think of this in similar ways to what this slide notes. You might conduct some survey and ask how people feel about gun control. So this is doable. This is really expensive. It takes a lot of time. You definitely have to have sensitivity to who you survey. Do you survey your friends, your family, people in your neighborhood? How many of those people do you actually survey? You could do polls, maybe on the internet, but then you have to worry about self-reporting and selection bias. How many questions do you create? How do you construct these questions? AKA, what words do you use to not persuade people in any one direction? So this is less expensive than surveys, but still pretty expensive because it's primary data collection. You could look at legislation, how states and the federal government fund gun control legislation. You could count votes. You could do this over time and over space. This is still pretty difficult. You've got to worry exactly what are you measuring. Are you measuring the legislation and how sort of the government works, aka lobbyists, veiled as American perception, or are you actually measuring the American people? Of course, you could look at gun sales, but this is difficult too because there's different legislation over space. How do you normalize some of these values? All tricky things. So a non-traditional approach might be to go to Twitter. And so here's just some R code. This is really easy to do. It's actually what we did to do this analysis. So the important sort of walk-away message here is this is, of course, secondary data analysis. We're not asking specific questions of the text, but it is quite comprehensive. We collected about 30 days, it was actually 60 days of data, but only looking just at December of 2012. Those 30 days produced about 210 million tweets, about 40 million users. When we downsampled and looked for the gun control type of conversations, we found that there were nearly 15,000 tweets and 10,000 people talking about this. So this is pretty important. If you were to do a survey or a poll, you would get much smaller sort of N. You just get less data. So the attempt of sort of inference is to make some sort of estimation of the population. Population here is the entire group under study. We can never examine the entire population. However, we can, with these sort of non-traditional data sources, get something that's small n, our sample, that doesn't exactly converge on big N. We'll never sort of reach that, but it is closer to big N than we would otherwise see in these sort of traditional pursuits. Okay, so so what does all that mean? We still have to evaluate the size of little n. Still doesn't matter if Twitter is not a model organism, if it's not representative of the people that the sort of population that is under inquiry. So I think a great example is the fruit fly. The fruit fly is used in laboratory settings all over the world, mainly because it's easy to breed and have simple life cycles. The danger, though, is what if the fruit fly is systematically different than other organisms in ways beyond just their sort of conveniently quick life cycle. So if true, the lessons learned from studying the fruit fly may not generalize to other species, and that's really what we're trying to do, is have external validity. We want to be able to generalize to other populations, or to the population. So this would be doubly problematic because their ease of use causes them to be focused predominantly on really important things, socially critical things like genetic research. So as we think about Twitter, the sort of converging, little n converging a big N is nice notionally, but we still sort of secondarily need to consider if whether Twitter is a model organism. So as such, analyses that rely on Twitter data, if not, analyses that rely on Twitter data may sort of mischaracterize the types of communications that we're interested in. Hopefully, with this case study, we'll sort of reflect the general utility in using some of these non-traditional data sets and hopefully showcase Twitter as a model organism, so to speak. Okay. So that leads us into hopefully some sort of illuminating insights about traditional versus non-traditional and sort of drawing parallels between good and bad. I often hear the statement about garbage in, garbage out. So don't use non-traditional data sets because it's garbage and subsequently anything that comes out of it is too garbage. So I sort of challenge us to sort of consider if this is a serious statement. We consider census data, surveys, polls to be authoritative. That's true to a large degree. The data also tends to be narrowly focused, however, geographically and or temporally. It's infrequently measured, if at all. So some of these are just ad hoc, one-off type of polls and surveys, and they're just snapshots, effectively. However, I think the sort of complexity of the questions, especially these socially critical questions that are emerging, just demand unique data. And so the tenuous point about authoritative data is really the linchpin is when this data is available, the vast majority of data, I think, relating to these emerging questions just do not exist. Twitter being such a blunt type of tool or collection platform really is that we could ask various types of questions. So I guess should we consider Twitter bad data considering the amount of signal and noise? It does have noise, but the amount of signal that it actually contains. Okay, so I think the message or the walkaway here is something very important, and that's the opposite of good data is not bad data, it's no data. That there's not such a thing as good data. All data has problems. Even if you were to perform your own field research and do your own data collection, which is expensive and tedious, you're still going to have dirty data and you're still going to have bad data and you're going to have to clean that up. You're going to have to curate it as it sort of grows in size over time. And bad data, really from a data analysis perspective, is what the job of the data analyst is to do, is to take sort of this bad data and sort of account for how much badness there is and risk is involved in using it and use it judiciously. So when we think about data, I think we just have to think about it as there is data and there is no data. And without data, we can't ask, let alone answer some of these questions. So the question still remains, is Twitter a model organism? I think the reality is that we live in an imperfect world. An imperfect world, we would naturally expect to produce imperfect data. Our job simply is to work with imperfect data. 100% of the time, that is what a quant or a data analyst is doing, working with imperfect data. Okay, so I'm glad everybody made it this far. I'm going to get into the case study. It's still a little bit of sort of pragmatism in trying to give some intuition behind the methods that were used. No math skills are required here, more intuition. If you're looking more on the sort of methods themselves and the mathematics, I would love to broach those perhaps offline. Okay, so what we did is we pulled together about 60 days of Twitter data. This is Twitter. This is data that can be collected from the Twitter API, which yields at no cost, so this is free. It yields about 1% of all tweets coming through Twitter. So what we did is we just throttled it to that 1%, took all that data, hundreds of millions of tweets, and then we sort of downsampled. And we downsampled the tweets according to these hashtags. And so what we wanted was to cast a broad net. So we were looking for a lot of signal. We were looking for people ultimately that were talking about gun control on either side, pro or against, and then we were also interested in people that were just talking generically about the tragic events in Newtown, Connecticut. Trying to get a lot of signal to ultimately derive or learn about what people were talking about in this time. So here's the data just thrown on a map for you to give you some sense of the geographic distribution. The column names are below. So this is sort of what we were working with. We had lat and we had long, so that's pretty important for the geographic aspect. We had timestamps. We also knew the tweet themselves, so what was the text that was contained inside of this tweet, and some other elements. So this was about 8,000 tweets ultimately that we were working with. Okay, so the technique. Hold on, I'm going to grab some water. Pardon me. So the technique that was used was something called a bag of words. Bag of words meaning that we weren't interested in how these sentences were sort of structured in a linguistic sense. The bag of words just takes all words, effectively throws them in a bag, not in any order. So we get things like, forget it, Donnie, you're out of your element, classic quote from Big Lebowski, and we end up with just these terms or words in no particular order. So Donnie, element, forget it, out, of, your, and your. So we do this for all 8,000 tweets, and so what we get is a bag of words for all of this text data. What we want to do next is to remove stop words. So stop words are things that really lack any discrimination. They're words that everybody uses, therefore are not very meaningful, right? So in the first example, we removed, it seems like your and of, it. So common words that are frequently used, therefore lack discrimination. The next task, this is sort of all in the pre-processing of things. What we want to do is take that text and trim it. So by trimming it, words that really do mean the same thing, run and runs, for example, become run and run. So we're going to just count these words, run, 2 times. So without stemming, we would have counted run and run separately when really we want to increase their efficacy by considering them to be the same thing. Okay. So the pre-processing of text is important. It's something maybe traditional social science research doesn't really consider, mainly because we work with a lot of structured data. So this data is already arranged in rows and columns and have cells, and the parsing in structured data is already done for you. This data is already parsed out for you. In unstructured text, we're dealing with tweets, so they're unstructured text. That parsing isn't done. So the pre-processing becomes pretty important to use in techniques like topic modeling. So the attempt of topic modeling is to group similar items, what we call really documents, but documents in this case, the Twitter example, are tweets. So we just want to group these things together. So Smokey, this is not Nam. This is bowling. There are rules. Walter talking about don't roll on Saturdays, and also he doesn't roll on Shabbos, are all sort of dissimilar to the other group of texts located on the right related to rugs, right? So what we want to do is be able to discriminate and find 2 groupings of data. Again, these are quotes from Big Lebowski, and if you haven't seen it, I apologize. But these are tweets talking about rugs and bowling. Okay, so I talked earlier about these sort of latent structures, and if our goal in the previous example was to estimate what what the sort of cast of Big Lebowski was talking about, what we want to do is estimate this middle part, topics. Topics, again, are latent. They're unobserved. So how do we estimate something unobservable, like themes or topics, what people are generally talking about, with observable things? So what we want to be able to do is look at the relationship between words in topics and topics in tweets to estimate this middle section of topics. So without going into the math, which is pretty sophisticated, what I want to do is sort of offer you a little bit of intuition and show you what these topics ultimately, how they ultimately materialized with the data that we used. So we ended up estimating this topic model, and we found 3 topics in the 8,000 tweets over those about 45 to 60 days. So topic 1 was a topic that seemed to capture discussions related to gun control and gun control rights as sort of a political issue. And you can see in the middle of this graphic is some of the top words to give you sort of intuition on what this topic ultimately described. And then you get some example tweets of people within this topic and how they sort of compose their messages. And you can see these decidedly have to do with civil liberties and also anger about the lack of gun control. So on both sides. So this makes no attempts to scale these users or these tweets on a one-dimensional scale from left to right, those people that are pro and against gun control. All it attempts to do is capture people who are talking about gun control itself. Okay. So topic 2 appears to be a little sort of generic. This is sort of a mixed bag of topics, and consequently, the example tweets that they discuss are a little haphazard, as you would expect. Topic 3, however, seems to discriminate pretty well compared to topic 1 and topic 2, and the folks in topic 3 seem to really be talking about the tragic events and expressing their sort of sympathy and sadness for the victims of Newtown. And you could see in the example tweets, my heart goes out for everybody affected by the shooting in Sandy Hook Elementary, a senseless tragedy. I can't imagine your pain. So not only are these people talking about the tragic events of Newtown, expressing their sympathy and sadness, they're also not talking about gun control, right? They're just showing their sort of empathy for the victims and the victims' families. Okay. So that's pretty interesting that we're able to take 8,000 tweets and decompose them down into just mainly 3 topics, and really only 2 topics of interest since we sort of had a mixed bag with topic 2. So that's interesting, but what we want to maybe do is go a little bit farther and find about the sort of usage patterns of these topics. So how do they vary either temporally, ideologically, or even geographically. So the next graphic I'm going to show you is actually time series. It's about, so the x-axis is showing time, date, beginning in early December and going out, early December, 2012 to January 2013, the end of January, 2013. And what we have is on the y-axis the frequency or the count of each one of these topics. So these topics are labeled to each tweet or document. And so we had about 8,000 tweets. So for each one of those, we get a label of each topic that it is most likely associated with. And so you see a couple things emerge pretty quickly. Is that topic 3, our sympathy topic, didn't exist until December 14th. So you see it fixed at 0, and then on the 14th, of course, the day of the shooting, it shoots up. People, an outpouring of sympathy and sadness, and however, also notice that within about a week, that topic 3 almost completely disappears. So it looks like right before Christmas, people are no longer talking about or expressing their sympathy for the victims of Newtown. So we noticed topic 2, which was that mixed bag, seems to be a mixed bag, right? It's pretty flat, it's pretty low throughout the entire time period. We don't seem to be missing anything sort of really important or seminal about topic 2. It is effectively the noise of everything that was left over from the model. The other valence that we captured, or topic that we captured, is topic 1. And that, of course, is the gun control debate. People talking, not expressing their sympathy, people talking about gun control. And so on the 14th, you see this debate, which did exist before the 14th, and not at an especially large rate or frequency, but it did shoot up on the same day of the event itself, and it's continued. And you could see that it spiked. So the 16th, so the decay from the 14th sort of extends even maybe a little bit beyond topic 3, the sympathy, maybe spurred on by Obama coming out just 2 days after the tragic events and sort of calling for action. He addressed the nations and called for meaningful action on gun violence. Topic 1, the gun control topic, again surges on the 19th, and that was again Obama talking about we have a choice, and we sort of can't accept events like this as being routine. So again, that gun debate surged on the 19th, and then you see it sort of taper off, and again, following Obama's his agenda on gun control, which included 23 executive orders on the 19th of January, again sort of pulse. So again, the topic model sort of captured this, and it surged on the 19th. So that's pretty interesting. We definitely have some models that tend or appear to discriminate. Their temporal distributions, appear to be pretty coherent and illuminating. So the next thing we might want to look at sort of the ideological, I guess, pattern usage of Twitter as it relates to the gun control debate. So what I did here is aggregated the data by red states, blue states, light blue, pink states, and purple states. So if you're unfamiliar, red state is a U.S. state that predominantly votes for or supports the Republican Party. Blue state is a state, again, that predominantly votes for or supports the Democratic Party. Purple state are those states that have sort of an equal level of support among voters, and then pink is some sort of hybrid. It's Republic leaning, but maybe not predominantly, and sort of conversely, light blue is Democratic leaning, but maybe not predominantly Democratic. Okay, so the way I sort of thought about visualizing this actually is sort of tricky to put on a map. So what I'm using instead is something called Mosaic Plots. So I'm going to give you a little bit of an intuition of how to interpret this Mosaic Plot, and then we'll look at a real example with our topics by red state, blue state sort of composition. So what we get with a Mosaic Plot is a square. A square would represent everybody. What we do with that square is we sort of slice it out and look at everyone by their topic. So on the left, we've got topic 1, in the middle, topic 2, and on the right, we've got this rectangle that is topic 3. These are proportional to the size of activity in each one of those topics. So you can see the most number of people talked about gun control, then that sort of mixed topic, and then ultimately sympathy. But all generally about the same. About 1/3 of the people were using each one of these topics over that time period. The next thing we want to do is we want to look at the volume of tweets, so the count just of tweets in each region, red state, blue state, purple state, pink, blue, light blue. And you see that Democrats tweet about twice as more frequently as Republicans, and then there are just varying proportions within the other geographic subsets. And then what we want to do is bring this all together, and we want to look at topics by geography. So what these are difficult to compare between geography in this example because these are proportions, right? So keep in mind, blue tweets out about twice as much as red. So, but what we can do is compare red states who talk mostly, not mostly, more about gun control, about 10% of their tweets about gun control, and the least about sympathy, right? About 8.5% of the tweets in those red states were captured in the sympathy topic. Conversely, blue states, Democratic states, they were talking mostly about gun control, more about gun control at about 18.3%. But sympathy wasn't their least performing topic. Performance maybe is not the appropriate word here, but sympathy and gun control were sort of being talked at an equal frequency. Subtly different for red states, and I didn't put the rest of the numbers up here, but I could certainly provide those to you, to anybody, who's interested in seeing the full sort of proportional breakdown between topics and geography. So something I'm pretty interested in and certainly talk about in my class at UMBC is spatially explicit theory. So spatially explicit theory are those social science theories that explicitly account for space. And this one, I think, is a pretty interesting one by Gartner, and it's a case study that looks at proximate casualties. So it's a hypothesis or an idea that popular support for American wars is ultimately undermined at the individual level more by deaths of American personnel from nearby areas than by deaths from those in far away. So if you've got a young soldier, a soldier of any age, who's killed in your neighborhood, you're likely to be adversely affected by it and ultimately have a poor sentiment of American wars than if somebody across the country lost their life, right? So there's this sort of first law of geography that we're just more affected by nearby things than we are by distant things. This is an example of spatially explicit theory. So what I wanted to know is whether this was generally true for the tragic events at Newtown. And so what I did, instead of breaking up the data by ideology, I broke it up by, and red state, blue state is sort of, in my mind, a good proxy for ideology, is in this case, we broke up the data by region. So the 9 U.S. regions, and what we wanted to do is look at that same two-way table in the Mosaic Plot between topics and regions. And so using the same intuition to interpret this Mosaic Plot as we did previously with topics and red state, blue state, is that we notice New England, those people closest to the event seem to be more affected by anybody else in this data set. So you can see the sympathy topic is far more prominent in New England than any other area. You also notice that New England, noted on the left-hand side, also has the smallest gun control topic. So not only were there just outpours of sympathy and sadness, they didn't seem to be altogether interested in in the gun control debate. There was certainly some discussion, but less than any other geographic region. And if we just sort of cherry pick here the mountain regions, thinking of areas across the country, these people seem to be pretty interested in gun control and less so in this sort of sympathy topic. So, I think I'm using or stealing a quote from Jay-Z here. What I like most about this notion of using non-traditional data is that in traditional social science research, it was hard to find data, and you had to do a lot of primary data collection. We have a lot of questions in the social sciences. We're definitely, but we seem to be, at least historically speaking, less invested. There's just less data, pardon me. Now, however, I think with some of the emergence of social media data and maybe sort of this outgrowth of big data, so-called big data, what you're seeing is that it's a super data-rich environment. That paradigm switched a little bit, and maybe we're sort of a theory-poor or data or question-poor environment. So the point is that where previously we had a lot of questions and no data, I think there is a lot of data, and these data I think could be really useful to answering some of these socially critical questions. So as a summary, we've, albeit in a sort of pithy format, covered some perspectives on counting. Why do we count? How do we count? Contrasting sort of that quantitative approach to counting versus a qualitative approach to counting. A little bit, hopefully you appreciate the difference between sort of classical measurement and modern sort of test theory, where we're trying to really get at these latent structures, which are difficult to measure directly. Traditional versus non-traditional approaches to social science inquiry. Little n to big N is important. It's often talked about with respect to non-traditional approaches, but really understanding whether or not Twitter and some of these other social media platforms are sort of model organisms for social scientific research. And the point that there is no such thing as good data and bad data. There's just data and no data. So the case study illustrates hopefully a sort of useful application of topic modeling to explore these latent constructs like sediment, which was our sympathy topic, as well as ideology, which was our gun control topic, and then the importance of looking at the variation of these themes and their usage over time and over space. So that's all I have. I will certainly open it up to questions, or if Erwin was going to take it back to moderate the questions. Here's my contact information, Keegan's contact information, should you have any questions or want sort of a deeper dive. I will note that in the next couple weeks, we are going to write up a more sort of comprehensive evaluation of this research, and we're going to put it on the Data Tactics Big Data Insights blog. So.
All right, Rich. Well, thank you very much. Don't go anywhere. I do have a few questions here that I'd like you to touch on. One thing is if people are interested in getting into big data analysis, I guess there's kind of two elements to this question. One, what are some of the key software tools for analyzing big social data? And also, where can you go and get this kind of data?
Good question. So I think I'll answer the second part of that question first. Where do you get some of this data? Twitter does have an open API, and so it is available. You could download the data either randomly, just pulling in all tweets at that 1% rate, which ends up being tens of thousands of tweets a day, or you could do something a little more judicious, which is just pull in words based on either keyword or geographic location. This is an API, however, so you need to use a tool like Python or R. To do it in R, you don't need a lot of expertise. I would say it's about 3 or 4 lines of code, Actually have the code available on my GitHub account. So it's pretty easy. You're not going to be able to do that through classical, maybe some GIS tools like ArcGIS, but certainly once you get it into R, you can export it into maybe a sort of traditional GIS. So I think that transitions nicely into what tools can you use. I use R, and R is an open source statistical programming language. A lot of people use R. Other people use Python. For this analysis, I used R and what's called QGIS, which is an open source GIS to do some of the mapping and the spatial joins and the sort of spatial operators. But you could easily use, instead of QGIS, ArcGIS. Desktop is a great tool as well.
What about some of the other sources of social data, social media data, big data?
Yeah, so I like Twitter the most. I think the types of relationships that exist with Twitter are a little bit different than Facebook, for example. So I'm a little leery of using Facebook data just because I think people often post stuff on Facebook, one, to their friends, so there's less of an emphasis on second order type of relationships. They're all first orders, friends to friends. So my sort of observation is they tend to be sort of written for the conventions of that day, where Twitter people are a little more open, just because there's this expectation that you're already using something that is open and on the web. There are certainly other useful data sets that exist, broadly speaking, on the open web, but contrasting Twitter to Facebook, I think Twitter is more viable as a sort of model organism.
Is there something less of a social selection bias with Twitter than there is with Facebook? Self-selection. I said social selection.
Yeah, no. I knew exactly what you meant. So that's a great question. The self-selection bias is a good one, or an important question to ask. I think yes, less so. You still have the selection bias that you're only getting data from people who have signed up and sort of agreed to use Twitter. Hundreds of millions of people use it. That might pacify you, but these are also people that you have to assume have internet connection. There's a selection bias there. I don't think anybody would reasonably argue that there isn't one. The question is, even beyond the selection bias, are people sort of constructing these messages in such a way that they're attempting to, in sort of, I guess, a disingenuous way, and I don't think that exists. I think there is a selection bias. I'm not sure how large it is. I don't know if it's so large to be meaningful, but I think people are still composing these messages in earnest and doing so in a genuine way, where you could get these like honest signals from Twitter. And I hope the case study for the attendees illustrated that point, that we get some pretty sensible and interpretable patterns, exactly what we would expect to find if we were going to do this in a more sort of classical way using surveys and polls.
So actually a final question here would be, if one were interested in getting started into big social data analysis, is there a good place to go and learn about these things? Of course, you know, there's some of our courses deal on the topics, but you know, web resources or good sites where people can go and get information on techniques and stuff like that.
Yeah, I guess we'll both shamelessly plug the program. I do teach a class that does touch on some of these topics. That aside, I'm not sure that there's one resource to learn about these things. Said it differently, I would have to give it a lot of thought. It's not just one place where you could go. It's probably a collection of a dozen different places that you would have to go to get little pieces of it. I did write a book called Social Media Money in R. Now I plugged two things that I'm working on, so I apologize. Social Media Mining in R is, I think, a good introductory book. If you're interested in like the scientific aspects of research, it definitely looks at using social media in a very judicious way rather than here's a bunch of code, here's how you do it, and buyer beware. Like, I'm not going to give you no intuition that you're doing something wrong. So it holds people's hand in that capacity. If that's inadequate, email me, whoever was interested in that, and I will try to send you as many URLs as I can, I think, of what I would consider to be pretty useful resources.
All right, excellent. Well, Rich, thank you very much for a very interesting presentation. Kind of the brave new world of big data out there, and I think we're going to be seeing a lot more of this kind of research and ideally interesting findings going forward. So thanks again, and thank you all for participating and attending, and I'm going to wrap it there. I think we have some closing slides, but everybody have a great day. And just a reminder, we have an information sessions 2 days next week regarding the MPS program. If you're interested or know somebody else that is interested, I encourage you to check out our webpage for an RSVP link, and we'll go from there. Look forward to hopefully seeing some of you next week. So thank you very much, and have a good afternoon.